continue. Okay, good afternoon, all of you. So today is our first session for this advanced technical training classes, and I am going to deal structural mechanics subject. Okay, so in this session we will learn some basic concepts and some objective questions on these basic concepts. Objective questions means this may be questions asked in GATE examination, questions asked in IAS examination, or any competitive examinations. Okay, so I am dealing with structural mechanics subject. Okay, so in structural mechanics there are two parts. In that, first is solid mechanics and second is structural analysis. So we will discuss point wise syllabus and then we will cover all points. Okay, so first part is solid mechanics. Already we have studied it. So in solid mechanics, first point is bending moment and shear force in statically determinate beams. Already these points we have studied it in introduction to solid mechanics subject. Okay, so in that we have to learn bending moment, shear force. What is meant by shear force? What is meant by bending moment? So basically, first you have to identify structure is determinate or indeterminate. Already you know that how to identify structure is determinate or indeterminate. So first point is bending moment and shear force in statically determinate beams. Then second point, simple stress and strain relationship. Okay, this is a basic and most important topic or point. Simple stresses. So what is meant by stress, then types of stresses, what is meant by strain, types of strains, strain, and relationship between them. Okay, in that also we have to discuss stress strain curve also, properties of material also. Okay, then next is theories of failure. I think this theories of failure part covered to division A, but this is not to division B because of 20% syllabus is reduced. Okay. Then simple bending theory, already we have studied it. Okay, then flexure and shear stresses. Shear and flexure stresses, we have studied it. How to find out shear stresses, how to find out flexure stresses, and equations. You know that flexural equation. Anyone, please, you have to remember flexural equation. Yes, please unmute and tell me flexural equation. Okay, then shear stresses, how to find out shear stresses. Okay, then next is uniform torsion, buckling of column, combined and direct bending stresses. This combined and direct bending stresses parts covered in structural analysis. So our first part, that is solid mechanics, already we have studied it. Then the remaining second part is structural analysis. In that we have to learn statically determinate and indeterminate structures by force or energy methods. Okay, force or energy methods. Already we have studied it. How to determine how to identify structure is determinate or indeterminate, and there are we have studied it two methods: force method and displacement method. Okay. After that, method of superposition, then analysis of truss, arches. Okay, analysis of arches we have studied it in structural analysis. Beams, cables, and frames. Then displacement methods. Okay, by using displacement method, we have to analyze slope deflection and moment distribution method. Already we have studied it, moment distribution unit. Okay, in that how to carry over moment, carry over factor, then how to calculate fixed end movements, already studied it. Then influence lines. This influence lines part we have covered in introduction to solid mechanics, stiffness and flexibility methods of structural analysis. That means whole points we have studied it in introduction to solid mechanics and structural mechanics. But for this session also we will cover this points. Okay, so first we will cover solid mechanics parts. Okay, in that first point, strength. Okay, already you know that strength means the ability of part or element of a structure to resist failure. Strength means you have to check the load carrying capacity of material without failure. That means you have to check. Suppose you have prepared 15 centimeter by 15 centimeter by 15 centimeter cube. Okay, I think this practical you have carried out in construction material and testing subject. Suppose you have prepared, I will plot here. Suppose this is our cube, 15 centimeter by 15 centimeter by 15 centimeter. Okay, likewise this 3D part. Okay, and you have to perform compressive stress. So strength means you have to check load carrying capacity. You have to check load carrying capacity of this block without failure. So this is called as strength. Okay, after that next point is stiffness. Stiffness means the ability to resist deformation. Okay, please remember basic difference between strength and stiffness. In strength, we find out load carrying capacity, and in stiffness we find out deformation. Okay, this is the basic difference you have to remember. Okay, after that next second point is assumptions made in strength calculation of structural analysis. So we have to study which assumption. So first assumption is the material of a body has a solid continuous structure. That means you have to remember only one: structure is continuous or body is continuous. This is first assumption. Then second assumption, within limit of the part of the body the material is homogeneous and isotropic. Now you mark this homogeneous and isotropic. Already we have studied it. When we say material is homogeneous and when we say material is isotropic, anybody have remember? Okay, I will
कोणत्याही
draw.
मटेरियलची प्रॉपर्टी सेम असते त्याला होमोजिनियस आणि डायरेक्शन सेम असते त्याला आयसोट्रोपिक प्रॉपर्टी.
Good. Okay, very good. Okay, homogeneous means if elastic properties are same at every point. Suppose you have to check elastic property here, then you check here. That means you have to check elastic property at every point. If the elastic property at every point is same, then this material is homogeneous. This material is homogeneous. And isotropic means if the elastic properties are same at various directions. Means you have to check elastic properties at each direction, and if the elastic properties are same at every direction, then this material is known as isotropic. Okay, got it? Then we will move towards next point. Here, homogeneous. A body is said to be homogeneous if it has identical properties at all points in identical direction. Homogeneous means elastic properties are same at every point, then this material is known as homogeneous material. And isotropic means a material is said to be isotropic if at any point it has identical elastic properties in all directions. Okay, when you have to remember that homogeneous at all points. Okay, homogeneous means elastic properties are same at all points. Elastic properties are same at all points. And when you are dealing with isotropic, at that time elastic properties are same at all directions. Okay, example, a fine grained material is mostly isotropic. If material is fine grained, then this material is isotropic. For materials like timber, concrete, and stone, these are the homogeneous. Okay, got it? Then next, Okay. Then next point, third point is very important. This third point is stress. Already you know that stress means force upon area. But here which type of area? Area is which type of area?
Cross-sectional area.
Cross-sectional area. Now you tell me definition of cross-sectional area. What is meant by cross-sectional area? Yes, already we have studied it. Anyone please? Now we will take just
Exactly perpendicular to the applied force.
cross-section area means area exactly perpendicular to applied force. Okay, area which is exactly perpendicular. See here, this is area and this area is exactly perpendicular to applied force. So this area is called as cross-sectional area. And stress means force upon area or internal resistance offered by a body against deformation. Stress is denoted by using sigma. So P upon A. Force is denoted by using P and area is denoted by using A. So sigma, which is equal to force upon area, and the unit of stress is Newton per meter square, Newton per mm square, okay, etc. Likewise. Now, types of stresses. First stress is normal or direct stress. Okay, normal or direct stress. So direct stress means if stress due to axial force. Okay, stress due to axial force. Normal stress or direct stress have, it may be either tensile stress or compressive stress. Here, if two pulls are applied, then this is tensile stress. If two equal and opposite pushes are applied, then this is compressive stress. This is first type. Then second, shear stress. Now see here. Here, which type of area is coming? In normal or direct stress, perpendicular area. Now see here, for shear stress, which type of area is here?
Tangential area.
Tangential area. This is our block, and for this side is fixed, and we are going to apply force here. Due to this, here this plane and force creates shear off. So this is called as shear stress. So please remember that here tangential force and here cross-sectional area. So shear stress is denoted by using tau. So tau, which is equal to force upon area. Okay. Formula is same, but area is different. In normal or direct stress, area is cross-sectional area, and in shear stress, area is tangential area, and F nothing but applied force. Okay. Then third type is bending stress. Okay, bending may be flexure. Okay, due to this tensile or compressive stresses are generated. In that, you have to remember this formula, FB, which is equal to M upon Z. Already you know that Z means section modulus. Okay. And MD or M is a component of force. M is a component of force and Z is a component of geometry. Z is a component of geometry. This section modulus is depend on geometry. So Z is the component of geometry and M is the component of force. Okay, you remember this formula, bending stress FB, which is equal to M upon Z. In that, M nothing but it is a component of force and Z nothing but it is a component of geometry. Okay, I request all students when I am discussing that particular points, you please write down this. Okay. Then last, stress due to torsion. Okay. Torsion means twisting or movements in torsional shear stresses. Okay. Got it? Stress means force upon area. Normal or direct stress. In normal or direct stress, applied force is exactly perpendicular, and here in shear stress it is tangential. Bending stress, either it may be tensile or it may be compressive. In bending stress formula, M represents component of force and Z nothing but component of geometry. Okay. Then next point, strain. Already you know that definition of strain. Yes, please recall this. Strain means
It is a ratio of change in length of an original length.
it is the ratio of change in length upon original length. Okay, good. And strain is denoted by using which letter?
Small e.
Small e or epsilon. Small e or epsilon. Strain is denoted by using e or epsilon. And strain nothing but change in dimension to the original dimension. It may be length or it may be any other dimension. So the deformation per unit length caused by normal force in its direction. So now types of stress. Already we have studied what is meant by stress and types of stresses. Now we will see what is meant by strain and types of strain. So strain nothing but change in dimension to the original dimension. So in that first type is longitudinal strain or direct strain. Longitudinal strain, at that time length will change. Then second type is shear strain. Shear strain. In case of tangential force, change in angle measured in radians. Here force is applied, and due to this force, shearing action is carried out this plane and this applied force, and some angle is created, and this angle nothing but shear strain. So in case of tangential force, change in angle measured in radians is called as shear strain. After that, volumetric strain. Already you know that volumetric strain, it is the ratio of change in volume to the original volume. Okay. Then next, fifth point. So types of strains, three types. First is longitudinal or direct strain, shear strain, and volumetric strain. Longitudinal strain means deformation per unit length. Means the dimensions of particular member change with respect to length. Then shear strain, that is you have to measure angle. And volumetric strain means change in volume to the original volume. These are the types of strains. After that, next point, Hooke's law. Already you have studied it from first year. So Hooke's law is within elastic limit or up to limit of proportionality, stress is directly proportional to strain. Okay, see here, sigma. Stress is denoted by using sigma and strain is denoted by using epsilon. So stress is directly proportional to strain. Okay, when this directly proportional removes, at that time one constant is present here, and this constant is called as Young's modulus. Okay, so E will, sigma, which is equal to E into epsilon. Okay, so please remember that this Hooke's law is valid up to limit of proportionality, up to limit of proportionality. And Hooke's law states that stress is directly proportional to strain. By mathematically, sigma directly proportional to epsilon. When this directly proportional sign removes, at that time this constant is added. Okay. Then next point, stress strain diagram. Okay, this is stress strain diagram. Now first we will see stress strain diagram for ductile materials. Okay, now we are the civil engineers, so we require two types of materials, ductile materials and brittle materials. So first we will see what is meant by ductile material. Okay, ductile material is one having a relatively large tensile strain up to the point of rupture. So first we will see what is meant by ductility. So ductility means ability to withdraw into thin sheet wires. This is called as ductility. So first we will see stress strain diagram for ductile material. In that we will see for mild steel. We will see for mild steel. Already you know that there are two types of two types of steels, mild steel and tar steel, also HYSD bars. So first we will see for mild steel. Okay, see here, this is stress strain curve. Please remember that on x-axis strain is present and on y-axis stress is present. Okay, now here first point, proportional limit. Now see here, up to this limit of proportionality, up to limit of proportionality, Hooke's law is valid. That is, stress is directly proportional to strain. After that, elastic limit. Already you know that. What is meant by elasticity? Yes, please, anyone.
Which regained its original and size after removal of force.
सेंटर पासून डिस्टन्स वर असतो तो लोड.
I am asking what is meant by elasticity. Elasticity.
Regain its original shape when force is removed.
If we are going to apply load on a particular material, after removal of load, this material or this body regains their original shape and size. This is called as elasticity. So this is elastic limit. Up to this limit, body regains original shape and size. After that, YU nothing but upper yield point. Okay, YU nothing but upper yield point, and YL nothing but lower yield point. Okay. After that, ES means ultimate stress, and B is rupture stress. B is nothing but rupture stress. So ultimate stress means higher stress. At that point, this particular rod or material load carrying capacity is over. Okay, this is ultimate stress. Got it? How many points are covered on this stress strain curve? O to A. O to A. Suppose here A point. Suppose here A point. This is B point. This is C. This is D. This is E and F. So O to A is limit of proportionality. A to B elastic limit. C is upper yield point. D is lower yield point. E, that is ultimate stress. Ultimate stress means highest stress. And F nothing but fracture point. And here necking region is formed. And this is uniform plastic elongation. Okay. Now from this limit of proportionality to from this limit of proportionality to this part is called as strain energy. This part is called as strain energy. Okay, please remember, from limit of proportionality to origin, this part contains strain energy. Okay. So this is our stress strain curve for mild steel. Then next, stress strain curve for tar steel. Okay, for tar steel and aluminum do not have specific yield point. Okay, so for aluminum or tar steel, okay, suppose we are going to conduct tensile test on tar steel. Okay, tar steel means which type of grade? Steel grade Fe, Fe 400 or Fe 500. Okay, and mild steel means Fe 250. Okay, please remember that mild steel means Fe 250 and tar steel means Fe 415 and Fe 500. Now you have to take tensile test on tar steel. It may be Fe 415 or Fe 500. For the tar steel, there is no any specific yield point, but for mild steel, specific yield point is there. So when we are going to perform test for this tar steel, at that time we have to use proof stress concept. Okay, already you have studied it, but I will explain once again. Now for this tar steel we have to study proof stress concept. Okay, I will read some part here. A line is drawn on the stress strain diagram parallel to the initial linear part of the curve, but it's offset by some standard amount of strain such as 0.002 or 0.2%. Please remember here 0.002, or if question is asked with respect to percentage at that time 0.2% and without percentage at that time 0.002. So see here, this is our original line. Okay, for tar steel specific yield point is not got. So we will draw some parallel line. Okay, one parallel line to this initial line, and this distance between this parallel and initial line is 0.2% or 0.002. So this is called as 0.2% concept or proof stress concept, and this is applicable for only tar steel or aluminum. Why? Because of tar steel and aluminum have no specific yield point. Okay, please remember this. Then this next third curve is for brittle materials. Already we learned for ductile material. In ductile material, two steels, mild steel and tar steel. Now we will see stress strain curve for brittle material. Stress strain curve for brittle material. Okay, brittle material means materials that fails in tension at relatively low values of strain are classified as brittle materials. So now you tell me steel or concrete. Which material is brittle, steel or concrete?
Concrete.
Concrete material is brittle because of it fell suddenly without giving any indication or without giving any warning. Those material fails, this material is called as brittle material. So for brittle material the stress strain curve is limited. So the for brittle material stress strain curve is limited, it does not vary. Likewise our ductile material, see the area of the area of ductile material curve is maximum, but for brittle material curve is very less because of this brittle material fails suddenly. Okay, so this is our stress strain graph for brittle material. Then next point is mechanical properties of material. Mechanical properties of material. In that, first property, elastic material. Already you know that elastic material means if we are going to apply load and after removal of load, material or body regains original shape and size, this material is called as elastic material. And plastic material is opposite to this elastic material. A material which can undergo permanent deformation without rupture is said to be a plastic material. Okay, plastic material means this body does not get original shape and size. Permanent deformation is occurred, then this material is plastic material. This property of the material is also known as plasticity. Okay, so this is also called as plasticity, and plasticity is important when a material is to be mechanically formed by causing the material to flow. Just you remember that plastic material means permanent deformation. If material which can undergo permanent deformation, then this is called as plastic material. Then next third property is ductile material. Okay, ductile material. Material which can undergo considerable deformation without rupture. Okay. So deformation is occurred but without rupture. So this is called as ductile material. Then next property is brittle material. Okay, material which ruptures with little or no plastic deformation. In brittle material there is no any deformation. Brittle material fell suddenly without giving any indication or without giving any warning. So this material is called as brittle material, and example of this brittle material is concrete, glass, brick. These materials are the brittle materials. Okay. Then elastic limit. Already we have studied it. The greatest stress. Elastic limit means up to that point material is elastic, or the properties of material or the dimensions